Hello students, I welcome you all to this class. Today we have an interesting topic to consider in mathematics, green theorem. In this video, we want to use green theorem to compute line integral. That's one of the benefits of green theorem. It will help you to evaluate line integral easily. So with the help of green theorem, line integral can be converted to what? Double integral. So let's see the statement of this theorem. If R is a region in the xy plane, R is a region in the xy plane, and this R is bounded by a closed curve C, and you have that P and Q are continuous function of x and y, and both of them have continuous first partial derivative in this region R. Then integral over the closed curve C of P dx plus Q dy is equals to the double integral over the region R partial Q partial x minus partial P partial y dx dy. So with the help of green theorem, this very line integral P dx plus Q dy can be converted to this double integral over the region R. So let's see how we can use this green theorem to compute this simple line integral. So let's look at this example. They ask us to find the line integral of find the line integral of 3y dx plus 5x dy such that your C, the curve C, is actually a straight line. We are having that x is lying between 0 and 1 and y is lying between 0 and 1. So solution. So we are going to apply this green theorem. So we are going to say let P be equal to, the one that goes with the x in this question is 3y, so be equals to 3y, and Q be equal to, let's see the one that goes with the y. The one that goes with the y is 5x. Q be equals to 5x. Then by the help of green theorem, we'll have that integral over the closed curve C of P dx plus Q dy is equals to the double integral over region R partial Q partial x minus partial P partial y. So we have the x dy. The x dy. So this is the statement of the theorem. So we need to get what partial Q is, partial x, and we need to get what partial P partial y is. So now partial Q partial x will be equals to, so see our Q here, right? And I have told you how to get your Q. From the theorem, we say the one that goes with the y is your Q. In this question, the one that goes with the y is 5x. That's why I call Q 5x. The one that goes with the x is your P, and the one that goes with the x here is 3y. That's why I call P 3y. So if I do partial derivative of Q with respect to x, so see my Q, I will differentiate it with respect to x, so I will get 5, right? And partial P partial y, according to the green theorem, you differentiate P with respect to what? Y. So C of P differentiate with respect to y, you are going to get what? 3, right? So now we are going to use this, see the question given to us. So by the help of green theorem, this question now, that's integral over the closed curve C of 3y dx plus 5x dy will be equal to the double integral over region R. See, in our region R, x is lying between 0 and 1 and y is lying between what? 0 and 1. So let me do for the first this thing. I will write the range of y here from 0 to 1, and this one for x for 0 to 1, right? So then, but what is partial q partial x? Partial q partial x is what? 5 minus partial p partial y. What's the answer? 3. Then we have the x dy. So which is double integral from 0 to 1, from 0 to 1. 5 minus 3 is 2, the x dy. So what you are going to do, you are going to first of all evaluate this. Let's evaluate the integration with respect to x. We are having double integral, so we integrate x first, after that we integrate y. So we have, let's leave the range of y is from 0 to 1. Then integrating x, you know we have a constant here too. I want to integrate with respect to x. Integral of a constant is that constant multiplying the variable you are integrating with respect to. Since we are integrating with respect to x, so the answer is this constant 2 multiplying x. So the answer to the integration is 2x. And the range of y is going from where? 0 to 1. Evaluated from 0 to 1. I will still have my dy, because after doing for x, I will now evaluate for dy, for the integration of y. So let's continue the solving here. We have integral from 0 to 1. Then evaluating this, we substitute the upper bound, right? So the upper bound, what is the upper bound here? 1. You substitute x for 1 here. So we have 2 times 1, right? Minus, you substitute 0, the lower bound. So we have 2 times 0. Then we have dy. So this is integral from 0 to 1. 2 multiply 1 is what? 2. Then you are going to have 2 minus 2 multiply 0 is what? 0. So 2 minus 0 is what? 2. So we are going to have 2 dy. Right? We are going to have 2 dy. So you are going to integrate this thing. So integral of 2 is the constant. Integral of 2 is this constant times the variable I integrate with respect to. That's 2 times y. So which is now 2y. Then the range of y is from 0 to 1. So you substitute. When y is 1, you put 1 here. I have 2 times 1 minus, when y is 0, you put 0 here. 2 times 0. So 2 times 1 is 2 minus 2 times 0 is 0. So the answer to this integration is what? 2. So you can see how green theorem has helped us to evaluate this line integral easily. So thank you so much for being part of this class. I'm expecting you in our upcoming class. Bye.